So sign convention for bending moments: clockwise moment to right is positive, or counterclockwise moment to the left is positive. And this is basically your positive bending moment. And the vice versa, yeah, the reverse is negative. So this is your negative bending moment. So also you may think that positive moment will cause compression or of the upper layer of the beam, and negative moment will cause tension in the upper layer of the beam. Suppose this is your beam sections and your moment so shape is look like this manner, and the upper side is your basically compression, okay. And now this is our neutral axis. So here is the compression. So as a compression, your bending moment symbol is your positive, and suppose the tension in the upper fiber, this is the upper area, this side is your basically upper side. So this is your upper side, then your bending moment is the tension. So just written down here. Also you may think that positive moment will cause compression of the upper layer of the beam, and negative moment will cause tension in the upper layer of the beam. So this is your positive. The second thing, suppose you have to apply the force in downward to upward, and your bending is beams look like after the apply the load in this manner. So here is your tension, and now so again I will say yes, I discussed in the I section. Okay, and then so this is your, so in this regarding, so here the bending moment you have to use the sign convention as a negative. So written down here the negative bending moments. Okay. So after the sign convention, the bending moment, how to represent on the notebooks in the positive sign convention, yeah, otherwise as a negative sign convention of the bending moments. How to represent on the notebooks? This is the simply I have to explain here. So this is your compression in top fiber area, and this is your tension in the top fiber area, and here is the neutral axis the member. Somebody will say here the natural axis, check the various books. So how to, you have to draw the bending moment diagram. So first of all, it is the very important, you have to draw a shear force diagram, then after you have to draw the bending moment diagram. So without shear force diagram, it is not possible to draw the bending moment diagram. So I have just go to take a one problem, and then through this problem we have got to solve the problem and draw a shear force diagram and bending moment diagram. So previous solve the problem, shear force diagram and bending moment diagram. So two things are there. One is in the side of the bending moment it's sagging and other is your hogging. So basically the bending moment at a section XX of a beam is the moment tending to bend the beam and the produce bending stress in the material of the beam. So this is basically sagging and here is the hogging. In the sense of, so which period I will draw here the figure. So here is the sagging and this is your hogging. This is the sagging and the chord of the sagging. This is very important. In the during the bending stress, that means here word is used, the bending moment of a cross section axis of a beam is the moment tending to bend the beam and produced bending stress. So here bending stress. We are studying in the next lecture. So bending stress in the material of the beam. The next topic is your how to solve. So I am going to here the problem. So draw the shear force and bending moment diagram for the beam. So how to proceed and how to you have to draw the shear force diagram and bending moment diagram of this problem. So now, first of all, you have to draw here. So what is your problem? Draw shear force diagram and bending moment diagram. Okay. So what is your figure? What is your problem? Just you have to watch. So this is your R1 and R2. Then you have to apply a load. So here is your 10 kilonewton. Then after you have to apply the load. So this is your 20 kilonewton. Then again you have to apply the load. So this is your 20 kilonewton. Then again you have to apply the load. So this is your 30 kilonewton. And the distance here to here, R1 to 10 kilonewton is your 2 meter. Then from distance from to here also is your 2 meters. From here to here also given in the problem is 2 meter. And from here to here, in short the problem is given the 4 meter. And from load 30 to 20, 30 to R2 is our. So now, so from this point 2 meter, then again 2 meter, then again 2 meter, and this is your 4 meter, and again your 2 meter. So draw the shear force diagram. So what you have to do there first, So I go to the determine the reactions. First of all, I have go to determine here the reaction. Determine reaction. How you have to determine reaction? So taking the moment about R1, taking the moment about R1. Okay. So just go to here. About R1. So clockwise moment equal to your anti-clockwise moment here. Okay. So which time period you have to use the taking the moment about R1. So just I have go to explain here. So here. So at present time what is the equation of the moment? So moment is equal to your, again I will say here, R cross product of the F. So I am not defining at present the I and J. So already you have to explain in the previous classes how to find out the direction of this moments. Okay. So just I go to the calculate here the problem. Just I to got how you have to calculate the value of R1 and R2. So I am not explaining here. So what is the direction of the moments at present time? Previous class already I will discuss. So now, so 0, 0 multiple R1. Then after go to the plus symbol, 2 meter. Then multiple here. This value is your minus 10 kilonewton. Then again plus. So 4 meter distance total from 0 to R from R1. So this is your 20. Then again come to the plus symbol to 6, and then multiple of your minus 20. Then after come to here the plus 10, and then multiple of your minus 30. And then after you have to plus, total distance is your 12, multiple of your R2 equal to 0. So this is your equation. So now come to your R2. R2 is equal to your, basically this is 0, here is the minus 20 and this is your plus 80. So just go to the conversion here. So minus 20 in the sense of here is the 20 minus 80, then plus 120, then plus 300 divided by 12. So divide by 12. So how many values? So minus that is your 420 and 440 minus 80. So 440 minus 80 is your 360 divided by 12 equal to your 30 kilonewton. So R2 the reaction value is my 30 kilonewton. Okay. So now R2 is 30 kilonewton. And through the equilibrium condition, now come to the equilibrium condition. What is your R1? So basically R1 minus 10 through equilibrium condition. I will say go to the equilibrium condition. Equilibrium condition. So R1 minus 10 kilonewton plus 20 kilonewton minus 20 kilonewton minus 30 kilonewton, and then again go to the plus. R2 value is 30 kilonewton. So this is the R2. R2 value is 30 kilonewton equal to our 0. So R1 equal to 10 kilonewton. So two values you have to compute here. One is the R2 and another is the R1. So R1 is 10 kilonewton, R2 is equal to 30 kilonewton. After the calculation of R1 and R2, so you have to go to draw the shear force diagram of this problem. So how to draw the shear force diagram? So first of all, you have draw a line okay, and then extend this line from here to here. Okay, and first R1. So again I will say explain here the some values. Suppose I will say here parameter is A, then B, then C, then D. So from here E and F. Okay, so A, B, C, D and F. So I will explain here. So at present time the point of A, your reaction force R1 is 10 kilonewton. So suppose you have to use a suitable scale and then after go to draw a vertical line. So this is in the positive 10. So vertical line in your 10 kilonewton. So the value is your here 10 kilonewton. From the A to point B, so your load is your 10 kilonewtons. So draw a horizontal line. Then after you have to watch one again loads of a 10 kilonewton in downward direction. So how we have to explain there? So first of all you have to take a cut section. So suppose I will say here A1 cut section. Here the cut section. So R1 is the 10 kilonewton. Then after come to the second cut section from these positions. Second cut section. So plus 10 minus 10 value is the 0. So now, so here come to the return back, the value is your 0, this condition. And then from this position to this, that means position B to C, your shear force value is 0. Shear force value is 0. So I will go to change here the color. It may be some issue. The next again cut section. So what happens here? Plus 10 minus 10 value 0 and again your minus 20. The shear force go to the force go to the 20 in positive. So now draw again one vertical line at the suitable scale. So here is our 20. And then again next come to here the sections. So this value is 20 plus and minus 20 value is 0. From C to D, our 20 kilonewtons, and then after come to return back as a 0. So here the value at a point D is the 0. And then next come to here at the point of E. So plus 10 minus 10 0, plus 20 minus 20 0, but here is the minus 30. So from the point D to E, your shear force is the 0. So I just take here the last section. Okay, the shear force is the 0, but at a point E, so your value is go to the 30 kilonewton in downward direction. So draw a line in 30 kilonewtons in downward direction. So this is your basically shear force diagram and already explained point by point in my documents. So now, so this is your shear force diagram. So here is 20 kilonewtons. The value is your 20 kilonewtons. and here is your minus 30 kilonewton. So simply I've written down here 30 kilonewton. Don't know with that, don't even. And here is your, through this manner you have to draw the shear force diagram. In the next, so how to compute the bending moment diagram? So it is the very important in term of draw the bending moment diagram. So again, so come to the next. So I go to compute the bending moment diagram and how to draw here the bending moment diagram. Bending moment. First of all, I just draw in as a bending moment diagram. This is called S.F.D, shear force diagram. Come to the compute bending moment diagram. Compute the bending moment. So now first I go to take equation. So bending moment diagram. So just assume here. So distance from point A to point B is 2 meter, and what is the bending moment of from point A to B, and what is the value? So must be in a very simple calculation here. 2 multiple 10, that 20 kilonewton meter. Very simple. But how to, you have to draw a bending moment diagram on the this problem. So just I go to the explain here. So my distance from A to B is 0 less than equal to x less than equal to 2, less than equal to 2. And your moment equation is m equal to basically 10 multiple x. So equation number your 1. So at x equal to 10, x equal to 0, so the moment is your 0 kilonewton meter. And at x is equal to 2, your moment is your 20 kilonewton meter from the equation number 1. And just watch here the sections. So I go to draw, extend this line again. This is your basically reference line. You have to draw on the notebook just like as a reference line. So here at point 0 your bending moment is the 0, but at a point B your bending moment is 20 kilonewton. So just draw a line from here to here. This is 0 and this point is our 20 kilonewton meter. From point A to B. Now come to in the second point here, the section, this point. So now again go to the cross section from here, second number section. So write down here the equation number B. So 2 less than x less than 4. So 2 is less than equal to x less than equal to 4. So we'll define here the distance of this value. So what is your moment? So your moment equation is m is equal to 10x, and now in the sign convention, so this is our downward direction, so I have take here the negative minus, then your 10 x minus 2. So x value is explaining here the distance from the point number A to B, B to C, etc. And this is your equation number 2. Equation number 2. So at x equal to your 2, so what is your bending moment? So moment is equal to your 20 minus 0, so 20 kilonewton meter. And at x is equal to your 4, what is your moment? So moment is equal to your 40 minus, so here 40 minus 20 is again 20, that means here the constant. So again this means just substitute the value of x equal to 2 in this equation number 2 and x equal to 4 in equation number 2. So both values are the same in the 20 kilonewton meter, 20 kilonewton meter. That the meaning of your here the force value is your 0, this time period your so now from this point to this point our moment is your point B to C, our moment is by 20 kilonewton meter. The next step again come to from this position, from here cut section of this, the third number step. So write down here the C. So value is your 4 less than equal to x less than equal to your 6. Less than equal to 6. So your moment equation is m equal to x minus 10x minus 2, and then the value of the upward directions, so plus 4, here the plus 4, in the sense load is your what? Load is our 20. 20 is in upward direction here. So now I will say here 20 x minus 4. 20 x minus 4. So this is our third number equation. And again calculate the value. So at x is equal to 4, so your moment equal to m equal to, so here 40 minus 20, this is your 20 kilonewton meter, and at x is equal to your 6, so what is your moment? Moment equal to your 6, that means 60 minus 40 and plus 40, so minus 40 and plus 40, so here is the 60 kilonewton meter. Now again come to draw the line from point number C to D, so 0 to 60, so here is your 60 kilonewton meter. Then after come to compute the bending moment on these locations. So first section, second section, third section, C number, and the fourth section from here. So go to D. So this total distance is your 10. Okay, 6 less than equal to x less than equal to 10. So now write down here the equations. So moment is equal to 10x minus 10 x minus 2 plus 20 x minus 4. Then the symbol is your, again in the normal direction, value is the minus. So minus 20 x minus 6. So minus 20 x minus 6. Equation number, the equation number is your 4. Equation number is your 4. And substitute the value of x value at x is equal to 6. Then your moment is, calculate here in the same manner, 60 minus 40 and plus 40, that means 0, and here is the 0 value 6. So the value is the 60 kilonewton meter. And when at x is equal to your 10, so what is your moment? So moment equal to your, I would have done here 100 minus 80, then plus 120, then minus, value is your 10 and 4, that means of 80, means of 80. Okay. So what is your moment? At the 10, here the moment is, just put the compute here. So this minus and minus 160. So 220 minus 160. So 220 minus 160 is the value of the 60 kilonewton meter. So again, from the point of D to E, from the point of D to E, our 60 kilonewton meter. And now till the E, 60 kilonewton meter. And the last, so from E to F point, in the sense of always at x equal to 0 in the meaning of A, at x is equal to 2 and the meaning of point B, at x is equal to 2 meaning of the point B, at x is equal to 4 meaning of the point C, at x is equal to 4 meaning of the point C, at x is equal to 6 meaning of point of D, 6 here D. So just how to compute, written down here the point number A, B, how to compute B, then location of this C, then after come to here D, then after come to here E. Until the end, so in the last number per section, so first, second, third, fourth and fifth. In the fifth number section, and at the E, so 10 less than equal to x less than equal to 12. So what is the moment equation? So moment equation equal to your 10x minus 10 x minus 2 plus 20 x minus 4 minus 20 x minus 6, and the last is the upward direction, R2 is your upward direction, that is plus, and the total distance is your 12 So previous of this section, so here the section, so value is your 30, so plus 30 x minus 10, x minus 10, so moment equal to, so just you have to watch here, this is your downward direction, oh shit, this is your downward direction, not in the plus, sorry, so downward direction, so first of all, go to the minus, symbol here is the minus. Okay, so now check the moment about x is equal to 10. After the computation of moment, so value is your 60 kilonewton meter. At present time your value is 10. And then x is equal to 12. So compute this problem. So m will be equal to your 12. So here is the 120 minus 100, then plus your 160, then minus your 120, then minus your 60. So value is, moment's value is your 0. From 120 to 120 they cancel out, and this is your minus 100 and minus 60. So minus 160 and plus 160 is your cancel out, and then after your moment equal to 0. So moment value equal to 0 kilonewton meter. So you must be drawn here the one another line from E to F, the moment will be 0. So this is the technique, you have to compute the value from this manner, and then after complete of this process you have to verify so this problem is right or wrong. How you have to verify the shear force diagram and bending moment diagram is your right or wrong. So first of all, so where your shear force value is constant in the sense of 0, here bending moment is the constant. Just you have to watch. First number step. Second number step, so difference between 2 points of the bending moment is equal to the area of shear force diagram. Again I will explain here. Difference between 2 points of the bending moment diagram is equal to area of the bending moment diagram. That means difference 20 minus 0 is the 20 kilonewton. So what is the area of this? 10 multiple 2, this is your 20 kilonewton meter. This is area. Second number is 0. B to C the value of the 0, here what value is our 0. Third number, from difference from here to here. So 60 minus 20. 20 minus 20 is the 0. 60 minus 20 is the 40. Difference of the bending moment, 60 minus 20 is the 40. What is our area? 20 multiple 2, the area is our 40. And third, 60 minus 60, my difference, my value is the 0, so here is the 0. And next, come to here, 60 minus 0, 60 kilonewton meter, here 60 minus 0. Now come to here, this area 30 multiple 2 in the 6 of 60. So now very easy, you have to verify this problem is right or wrong. Very simple. The difference between the 2 points of the bending moment is equal to the area of the shear force diagram. This is the procedure. So today, so I am going to close this session, and I have tried to upload this video on your YouTube. In future you have to help and watch and up to my class. So thank you very much.